Use the properties of logarithms and the logarithm property of equality to solve the logarithmic equation. The equation we want to solve is 2 log of x plus 5 equals log of 16 plus log of 4. Now we're going to use this one-to-one property of logarithms, or the way that your book calls it is the property of equality, which says if you have log with the same base on each side of your equation, then what's inside of those logs must be equal to each other. So this provides us a way for simplifying logarithmic equations to something we're a little bit more comfortable solving. Now we want to do that with our equation, but you can see that on the left of our equation we have a single log, and the right of our equation we have a single log. And in our example, we have a log on the left with a coefficient, and we have 2 logs on the right that are added to each other. So we can use some properties of logarithms that allows us to condense and simplify these expressions first. And once we rewrite it in this form, where we have a single log with the same base on each side, then we'll proceed with solving. So on the left, I need to deal with this coefficient of 2. And there's a property of logarithms called the power rule, which allows me to move that to move the coefficient into the power. So that would mean on the left-hand side that I would have log of x plus 5 squared. And then on the right-hand side with this plus sign, I'm going to be able to condense these logarithms with a property called the product rule. And it's called the product rule because we multiply the numbers inside of each log. So we're going to multiply 16 times 4. So that's going to give 64. So on the right-hand side, we have log of 64. So now we've written this equation with a log of the same base on each side. Take a second to see if you can remember what base is being used for these logs when we don't specify. When we don't specify, that means we have a base of 10. So this actually means log base 10 of x plus 5 squared equals log base 10 of 64. So we're able to now use that property of equality and say that x plus 5 squared equals 64. We can make an equation out of the expressions inside the logs. So now we'll continue to solve. This is a quadratic equation. I'm going to solve with the square root method. So I square root the left and square root the right. On the left, the square root and the square cancel each other out, leaving me with x plus 5. On the right, I have plus or minus 8. I'll subtract 5 on each side, giving me x equals negative 5 plus or minus 8. Negative 5 plus 8 is 3. Negative 5 minus 8 is negative 13. Now with logarithmic equations, you need to check to make sure that your values are in the domain of the original function. So let me check x equals 3 in the original equation. That's 2 log of 3 plus 5 equals log of 16 plus log of 4. And when we check, what we're checking for is to make sure that our value is in the domain of the log. And we can only take the log of positive values. So we're checking to see if this expression inside the log is positive, and 3 plus 5 is positive, and these other expressions inside the log are also positive. So we're going to keep the solution of 3. Now let's check the other solution of x equals negative 13. That would give 2 log of negative 13 plus 5 equals log of 16 plus log of 4. And you can see that this expression inside the log, negative 13 plus 5, would give you a negative value, and the log of a negative is undefined. So we're going to throw away that solution of negative 13 and keep only x equals 3 as the solution to this log equation. Thank you for checking out my videos. Have a great day.